Hi, my name is Lara Tavernier and I'll demonstrate for you the Antwerp dashboard that has been created within the CUTLER project. The City of Antwerp has worked out one process within the Antwerp CUTLER dashboard, and that is the decision on the location of a garden street and the evaluation of this measure. As a reminder, garden streets are streets that have more greenery and more water retention capacity than other streets. This is achieved by the use of permeable materials, planting plants and trees, providing water elements such as small ponds, and installing water tanks underneath the surface. On the picture on the left, you can see a concept drawing of a garden street, which shows all the different measures that could be implemented in a garden street. And this is currently being done right now in the Lange Ridderstraat, which we used as an example for this use case. And you can see a picture of the streets on the right. Why are garden streets an important measure? Well, the more garden streets in the city, the more we create climate resilience. More water buffering during rain peaks will prevent some of the heavy floods that occur nowadays and will also relieve heat stress during very dry periods. As a policymaker, however, it is difficult to decide on the locations for potential garden streets. There is one garden street that is nearly finished, but how to prioritize on where the next garden street should be implemented? And that's why the objective of the Antwerp CUTLER dashboard is to support this decision-making process by providing environmental data about rainfall and water levels and providing a cost-benefit analysis of implementing a garden street. And of course, social aspects are considered as well in the form of socioeconomic data and sentiment analysis. So let's go to the dashboard right now. Here you can see the dashboard with the one process that has been created for Antwerp. As a policymaker that lives in Belgium and speaks Dutch, I can change the language to Dutch and the whole process will be in this language, so all the titles have been translated. However, for the sake of this demonstration, I will leave the language in English. I will start a new process right now. A new process has been created, and now I can see an overview of all the tasks that I need to go through. There are 5 tasks, and the first 2 tasks will be a part of the information phase. Here you can see the information phase that is twofold. In the first part, I will get an overview of historical data. It's data about rainfall and groundwater levels. And in the second part, I will get an overview of all the real-time data that is available. For the policymaker from the Department of Energy and Environment, it's very useful that this information is collected here in one place. It gives an insight in the average and peak rainfall during previous years, and it's a baseline to compare the real-time rainfall and water levels with. As you can see here, there are different widgets. First of all, there's a map that shows all the locations for which information is available. The color of the dots show us the average height of the rainfall. The darker the dot, the higher the average height of rainfall, and the size of the dot shows us how much data is available for this location. And then there are different widgets that show the data in a different way. So we have a table, we have a cumulative graph, and a bar graph. If I am interested in one specific location, say I'm interested in the data from the Kernenergiestraat, then I can select it using this filter. I can check on the map that it's indeed the right location, and then again I have the information in the form of a table and the 2 different graphs. I could also choose to download the information using these links. Then if I want to see again the data from all the measurement points, I can simply delete the filter right here. So this is the first part about historical rainfall. The second part are historical groundwater levels, which I can visualize right here. Again, we have a map with the different measurement locations and a table, and again, a graph. If I'm interested in a certain location, then I can select a certain well code. For example, 96 is the well ID for the Middelheimlaan, as you can see here, and then I can only see the information for this measurement point. If I am done with observing the historical data, I can finish this task and go to the next one. Now I am in the second part of the information phase, which is the information phase about the real-time data. And this is a real added value for the Department of Energy and Environment because it's the first time that we are able to consult all the real-time data with regard to water in one place. We even installed extra rain sensors during this project. And all the information that you can see here is also publicly available as open data. There are two things we can inspect. I will start with two graphs which show the water level in the ponds of two city parks. So the one here on the left and the one on the right show the water levels. And why is this interesting? Well, for a policymaker that designs garden streets, it's interesting to see to get insights from the water levels of certain ponds because it's a good indicator for drought. Garden streets are especially interesting to implement in areas with a low groundwater level. And then I would like to say the rain peaks that occurred in a certain period. For example, in February this year. So I'll go to February 2021. And then I'll update it. And then I'll only see the information that's available for February 2021. And then I can clearly see the rain peaks that occurred and how big these rain peaks were. And that's also very interesting to know because if those peaks are getting more frequent or consistently bigger, then measures need to be taken to expand water retention capacity in the city. Otherwise, there will be too much rain flowing to the sewers, resulting in floods if the capacity of the sewer system isn't sufficient. In case of our garden streets, the more and heavier rain peaks mean that we should install more water buffers, such as more or bigger underground water tanks. So these rain peaks really give an insight in how to design the garden streets, while the information about the groundwater level gave us already an indication on where a good location would be for a garden street. So when I'm done visualizing or observing all the real-time data, I can go to the next phase, which is the advice phase. So now I'm in the third step, which is the advice phase, and which incorporates socioeconomic aspects. I can get information and insights and can further help me as a policymaker with a decision about suitable locations for garden streets and give me an insight in socioeconomic impact of creating the garden streets. The most interesting in this advice phase is an interactive tool that has been created. It has been implemented in a dashboard, but it's to help with the visibility. I will open it in a separate tab so I can show you the tool a bit bigger. Something very interesting about this tool, which will help me as a policymaker to decide on good locations for garden streets, is that I have two different kind of layers. The first kind of layer is about the flood maps. There are three different flood maps. First of all, for flooding depth T05, then T20 and T100. A flood map T05 shows me the floods that will occur for floods that happen once in 5 years, while the T100 shows the floods that occur once in 100 years. So they are less frequently, but they have a much bigger impact. So this gives me a first idea of where the big floods will happen. So I see here in the south of the city and also here in these areas, there will be once in 100 years, there will be big floods. If I show the same map for T05, that narrows it down also a little bit. So this would be an interesting area here as well, and here in the south as well, would be already, gives an indication that would be interesting to implement a garden street. Then I can also choose to visualize some other layers, for example, the available public green surfaces. The lighter the color, the less available public green space. So here, all the areas that are white have not a lot of public green space. And for example, these purple areas are parks which have obviously a lot of public green surface. Then another thing I could check is the poverty index. The higher the color, or the darker the color, the higher the poverty index is. So it's also good to check that we don't only implement measures in the richer areas, but we also implement these garden streets in more poorer areas. And then I can also show you already an economical impact of implementing garden streets, because this layer shows the direct benefit of implementing a garden street. How is this calculated? Well, it uses the flood maps, and then it calculates all the costs that are related to a certain flood. Because if there are floods, there are costs of repairing buildings, repairing streets, and so on. And by implementing a garden street of a certain type, these floods can be avoided. So the direct benefit of implementing a garden street is actually translated into avoided costs by implementing a garden street. And there are three types. Type 1 is a type of garden street that only uses measures above the surface. Type 2 also uses some measures underneath the surface, such as a water tank. And type 3 is best to describe as a full option garden street. So all the measures that are available will be implemented in type 3 garden streets. So from visualizing all these different layers, I can see that, for example, here in the south would be an interesting place to implement a garden street, because there were a lot of floods. There was not really a lot of public green space. It was this lightest color, and there would be an interesting economical benefit. So I will not show this layer and zoom in a little bit. I can see, for example, that these streets, there would already be big floods with T05 floods. So let's say it's interesting to further investigate the benefits of implementing a garden street over here in the Beukerstraat. I will use a pin, and I place it over here. And I can also say that, okay, for example, I will also investigate this one and this one. Then I'm done with placing markers, and then I first will investigate this one over here, and then I can click on the marker that has marked all possible interesting locations, and I will create a garden street here. The name, I will simply put in the name of the street. It's the Beukerstraat, and it's not already existing. It's something I propose as a policymaker, and I will be proposing a type 1 garden street with only measures above the surface. Eligibility, I can't select right now. I need the calculations for that, and then I can edit it later on. And then the only thing I need to do is select the area of this garden street. And that will be used to calculate the costs. Because within this tool, the cost is calculated with a typical cost of a garden street of a certain type, multiplied by the cost per square meter. So now here I see the list of all the garden streets that have been investigated, so all the ones with these kind of gray or green markers. And then in the table, I will go to the Beukerstraat, which is the one I've created right now. And then I see 9 columns. So for every type of garden street, I can see the benefits. So actually the avoided costs by avoiding floods in the future, the cost of the garden street, so the cost per square meter multiplied by the area of the garden street, and then the profit, which is obviously the benefit minus the costs. And then the same is also done for a type 2 street and a type 3 garden street. And then I can immediately see that I have positive profits for a type 1, type 2 and type 3, and that actually the profits for implementing a type 3 garden street are very high. So that's very good. And that's why I will edit this, and I'll indicate the eligibility for each type, because each type of Garden Street has a positive outcome. If you want to compare it, for example, here the Azielaan or Bergenhoeve, they both had a negative profit, so that's not very interesting to consider. So that's how this tool works. And as a policymaker, then I get a very quick overview of where there would be interesting garden streets. For example, this one is already marked green because I marked the eligibility for 3 types of garden streets. And the same has been done for some other streets in this area. So that's what I wanted to show you with this interactive tool. And then we go back to the dashboard. I finish this and then I go to the next task, which is a part of the monitor phase. In the monitor phase, we have implemented a Twitter tool so we can monitor the social sentiment of a garden street. For example, I can put here a search item. I will edit a bit the time range. And then I'll see all the tweets that have been tweeted about Tuinstraat. We see there have been 59 tweets. Some of them, most of them are neutral. Some of them in the green are positive and some in the red are rather negative. But as you can see, there is apparently also a Tuinstraat in Amsterdam, which is related to the more negative tweets. If I search for another green measure, groendak, which is green roof, I see more positive sentiments. And then I can also, which is very nice, so I can see when these tweets have occurred, I can see the actual tweets, and I can also see some pictures. It would be also very interesting to monitor during the roadworks or when they are renovating the street, if we would really promote as a city the hashtag Tuinstraat and really let the citizens know, okay, if there's something going on, if something bothers you, we can always use the hashtag Tuinstraat or maybe the hashtag of the garden street that is being implemented at that point. And then the city can monitor very well the sentiments. And then I'll go to the next task, which is already the last task. The last task is the evaluation of the impact of implementing the garden street. And how does this happen? Well, I'll go to my presentation once again, because it's more easy to visualize it this way. So the idea is that the garden street buffers more water, more rain, and that less rain will go into the sewers. So here we see an image of a situation without a garden street. So it rains, there's some rain going into water tanks, but most of the rain is going to the sewers. In the situation with the garden street, more rain is buffered, so less rain is going to the sewers. And that's what we are using for evaluation. So there's a water sensor implemented in the sewer of the Lange Ridderstraat, and then we can calculate when this street is finished, how much water that is going through the sewers. And then we have also simulated the situation, how it would have been without the implementation of the garden street. So you can see it over here. So the bar graph shows the rainfall, and then you have the queue, so the flow going through the sewer, and the red line is a simulated line, and the yellow line is the observed line. Now these lines are on top of each other because the garden street is not finished yet, so the observed flow through the sewer is the same as the simulated without the garden street. But in the future, we would like to see that the observed line is lower, so that the flow will be lower than the simulated version of a situation without the garden street. And that's how we will measure the effectiveness of this measure. And when we hopefully in the future will see that there's a positive impact, then I can submit this form and go to the next task. But actually, that's the end of the demonstration. And I would like to conclude that CUTLER dashboard is really a tool that supports in the decision on the location of a garden street and also helps evaluating the measure. And these kinds of measures are now usually taken based on the knowledge of experts, but also a bit on a gut feeling. So it's a good thing that the Department of Energy and Environment can now evolve to more evidence-based decision making, and because thanks to this project there has been a better awareness also of the importance of data and how it can help for decision making. The best proof of this is that in the climate plan for Antwerp that has been approved in December 2021, there's one action that's specifically about the use of environmental data, which was inspired by CUTLER. So we are sure that the good work that has been done in CUTLER will be used in the future and will form an important basis for even more data-driven decision making. Thank you for your attention.